In the spring of 2026, the AI frontier moved at a staggering pace. Labs consistently shipped models chewing through complex data faster than ever. This structural diagram illustrates Anthropic's entry into that release cycle, Claude Opus 4.7. Positioned as a bridge to their next-generation models, it launched with a 1 million token context window and a 3.75 megapixel vision capacity, triple the resolution of its predecessor. These specifications suggested a new ceiling for model performance. However, within hours of the release, developer forums erupted with an unusually fierce backlash. This Reddit discussion captures the reality on the ground. Users labeled the new model lazy and unreliable. They reported hallucinations, like the AI inventing fake coworkers or fabricating software packages, and documented broken workflows and environments that ran reliably just days earlier. We see the core contradiction in this split-screen diagram. On the left, Opus 4.7 sets a record-breaking scores in laboratory evaluations. On the right, public sentiment crashes immediately. An AI engineered to be objectively superior is actively frustrating the humans trying to work with it. Making sense of this requires looking past the marketing copy. We have to look at the raw telemetry of how these models are evaluated internally and compare that against how they actually operate in production. Anthropic's claims are grounded in specific metrics. On this chart, the SWE Bench Pro column shows a 10-point jump for Opus 4.7. Moving across, the model posts gains in scaled tool use and a 13-point surge in visual reasoning, meaning it accurately reads complex interfaces. The both structured engineering tasks do not reflect casual, open-ended work. This 4-quadrant grid maps out the friction patterns everyday users hit. In the top right is quiet quitting, where the AI stops a task mid-thought. On the top left is consonant hallucination, where it fabricates definitions for its own built-in commands. A closer look at the data reveals the source of this friction. This 3-panel slide highlights documented regressions. The left panel shows a drop in browse comp, a benchmark tracking open-ended web synthesis. Then there is the cost. The central pie chart illustrates a tokenizer that burns through user context on its 35% faster. The raw data paints a specific picture. The model is not objectively weaker. It was weighted to prioritize structured execution and coding logic, sacrificing open-ended conversational synthesis and cost efficiency to achieve those specific gains. The friction users are feeling stems from a shift in the underlying architecture. Anthropic replaced the manual control system previously used by developers with a different engine. This comparison highlights the change. On the left is the older system, where users could track reasoning and tweak specific parameters. On the right is the adaptive engine. The model hides internal thinking blocks by default and locks out custom controls, creating an opaque experience. Locking down the architecture created technical consequences. This GitHub bug report documents a failure mode in the wild, silent stuck turns. Because the reasoning is hidden and the AI controls its own effort levels, agent sessions can hang during tool execution without emitting an error code. This brings us to the core issue, mapped out in this Venn diagram. On the left, benchmark agents require rigid command-style prompting. On the right, casual chat relies on loose does-what-I-mean prompting. Opus 4.7 sits firmly in that left circle. Opus 4.7 was tuned for highly structured tool use. The loss of flexible conversational intuition was a deliberate trade-off made to hit those engineering targets. To figure out who actually benefits from this release, we have to separate the complaints. This table categorizes the backlash. On the left are intentional design shifts, like strict literalism. On the right are genuine defects, like silent hanging bugs, which require patches. If you eliminate the actual bugs, the remaining rigidity transforms from a liability into a distinct operational asset for specific enterprise environments. This slide details where that rigidity excels. For hard software engineering, dense desktop UI automation, and complex financial or legal document review, a model that strictly follows directions and ignores conversational filler is exactly what production systems need. But unlocking that value comes with a mandate for developers. Dropping this model into an old pipeline will break it. Previous conversational prompts will fail, and explicit task budgets are now a mandatory requirement. The controversy surrounding Opus 4.7 signals a shift in the wider AI landscape. This graph visualizes the fracture. The industry is moving away from a single, all-purpose best model toward a spectrum of specialized domain experts. While Opus 4.7 optimizes for rigorous coding, models like GPT 5.4 lead in web browsing and synthesis. Leading developers are trading away the conversational warmth and accessibility that made these tools popular. They are prioritizing rigorous, benchmark-tested agentic execution over general human preference. This final diagram captures the takeaway. Opus 4.7 proves that laboratory benchmark success no longer guarantees product-market fit for human collaboration. The definition of intelligence is splitting.